All right, this is uh question question 6 of homework 2. And this just requires you to have an understanding of acceleration. If you do not understand acceleration very well, I do advise that you watch this video by Khan Academy or any other video on acceleration by perhaps Organic Chem Tutor. Understanding the concepts of acceleration is essential to solving this problem. If you understand acceleration, then this problem will be quite easy for you. So with that said, we're going to go ahead and start the problem. The problem is a commuter backs her car out of a garage with a constant acceleration of 1.4 meters per second squared. And part A asks us, how long in seconds does it take her to reach a speed of 2 meters per second? To reach a speed of 2 meters per second. Our answer here is going to be 1.43 seconds, but how did we acquire that? I'll show you how. Okay, so let's see what information they give us. Constant acceleration 1.4 meters per second squared. Our initial acceleration is A, 1.4 meters per second squared. How long in seconds does it take her to reach a speed of 2 meters per second? This does make the assumption that her initial velocity is going to be 0 meters per second. Because if we think about it, if you're backing out of a parking spot, your car is initially going to be parked, and that means that your car isn't moving. In other words, your velocity at that point is zero. It is going to be zero. What about our final velocity? Our final velocity is going to be how long in a second? A speed of 2 meters per second. 2 meters per second will be our final velocity in this case. And they're asking for time. We don't know time. Okay. I also like to sketch out what we're working with. So our initial velocity will be 0, where a is equal to 1.4 meters per second squared. And after some time, let me move this out because it's quite non-descriptive. I mean, it doesn't describe the environment very well. The car, window, car, right there. After some amount of time, we reach this final state where v is equal to 2 meters per second. The acceleration is possibly still the same. I'll put a question mark next to this. I must say right now, it really doesn't matter. So I'm going to remove this. So, what is acceleration? Acceleration, at least constant acceleration, uh, acceleration is going to be equal to a change in velocity or speed, whatever you want. We'll go with velocity over some period of time. This is the formula for average velocity. And this only works when your acceleration is constant. So, assuming that acceleration is constant, uh, or assuming that you've calculated the average velocity, average acceleration, then you can use this formula. So, if acceleration is constant or acceleration acquired is average, you can use this formula right here. So, let's see. Our change in velocity is going to be our final velocity minus our initial velocity. And we know the acceleration, which is 1.4 meters per second squared, is equal to some time, some change in velocity, which is going to be 2 meters per second minus our initial velocity, 0 meters per second. And this occurs over this period of time, which is unknown. So we use some algebraic manipulation. We multiply both sides by t, get rid of this, and divide both sides by 1.4 meters per second squared. we arrive at this um, final equation. T, we arrive at this final equation. T is equal to 2 meters per second over 1.4 meters per second squared. In other words, we're dividing our change in velocity over acceleration, our constant acceleration or average acceleration. And this gives us the amount of time that it took to acquire this velocity. In other words, this is the amount of time it took us to accelerate, um, to accelerate, and our difference in our initial velocity and our final velocity is this velocity. If that confuses you, just discard that. Don't worry. Okay, so t in this case will be equal to what is it? T is equal to 1.43 seconds in this case. Um, Now, if you divide 2 by 1.4, you get this funny looking number, 1.42857, and it doesn't end. So how did we get to this? How did we know to round this digits? Well, that is because of significant figures here. How long in seconds does it take? Let's see what we divided. We divided our change in um, our velocity, which was 2.00 meters per second, divided by our acceleration, 1.40 meters per second squared. This one, the rule of significant figures when it comes to division or multiplication is you take the one with the least amount of significant figures in total, and your answer has to have that same amount of significant figures. So if this is our answer, this answer needs to have the same amount of significant figures as the least amount of significant figures here. Both of these are the same, so we need three sig figs. Our answer needs to have three sig figs. So 1, 2, and 3. We need to round this in order to acquire three sig figs, and 1.42 rounds, 1.428 rounds to 1.43, and that's how we got our first part. So in conclusion, the amount of time it takes for her or him, oh no, her, the amount of time it takes for her to reach 2 meters per second, accelerating at 1.4 meters per second squared, is 1.43 seconds approximately. Next part of the question asks, if she then brakes to stop in 0.8 meters in 0.8 seconds, what is her constant deceleration in meters per second squared? And our answer is 2.5 meters per second squared. Let's see how we got that. Okay, so she then brakes to stop in 0.8 seconds. This is making the assumption that this is right after we've reached this this right here, because we were in the parking, she was in the parking spot. She accelerated to this point, and now her velocity is equal to 2 meters per second. Now at this state, this question is asking how long, if she brakes to 0.8 in 0.8 seconds, she comes to a complete stop. So in 0.8 seconds, her velocity is equal to 0 again. Velocity is equal to 0 again. What is her constant deceleration in meters per second squared? So from here to here took 2 seconds. Time took, 0.8 seconds. From here to here took 0.8 seconds. Let's use our formula again. Acceleration, we're going to use acceleration. This gives us average acceleration or at constant acceleration. And this is going to be equal to change in velocity over time. So what is our change in velocity? Our change in velocity is going to be our final velocity um, minus our initial velocity. Our final velocity is 0 meters per second. Our initial velocity is 2 meters per second. And the amount of time it took us to change this amount of velocity uh, is going to be 0.8 seconds. And this will give us our answer. And I did rush the first one in terms of sig figs, so I'll be a little bit more careful here. This 2 meters per second is this. So we have 3 sig figs here. And it's going to be divided by 0.8 seconds. 0.8 seconds. So how many sig figs will this answer have? Let's see. 1, 2, 3. This top part has 3 sigs. This bottom part has 1, 2, 2 sigs. So we take the one with the least significant figures, and that one is this will be the amount of significant figures our answer will have. So our answer will need to have 2 significant figures. So we have -2 divided by 0.8. Let's see, 2 divided by 0.8. That is going to be equal to 2.5. 2.5. Does this have 2 significant figures? 1, 2. Yes, it does. So we don't have to round it. We got lucky this time. So um, our answer is in meters per second squared, 2.5 meters per second squared. And that is the end of this video. If you are curious as to how I knew that the units are meters per second squared, outside of us looking for acceleration. Oh, my apologies. Negative 2.5 meters per second squared. Well, constant deceleration, since deceleration is negative, saying we decelerated at negative 2.5 meters per second squared is the same as saying we accelerated 2.5 meters per second squared. And that's not the case. We are decelerating. So in this case, it's just going to be 2.5 meters per second squared because the deceleration is equivalent. If you say you decelerated 2.5 meters per second squared, that's equivalent to saying you accelerated negative 2.5 meters per second squared. Okay, so back to what I was saying earlier. How did I know that it was in meters per second squared? Well, that is because if you take these units, you have velocity. Velocity in this case is going to be meters per second. And you divide that by the time, which is typically in seconds. And what we get is meters per second per second. In other words, meters per second times second, which is equal to meters per second squared. So that is this video. I hope I was able to explain this pretty well. And I will see you guys when I see you guys. Adios.